Hello everyone. Welcome to this video lesson on security testing strategy and plan. Today, we'll cover everything you need to know about security testing and software development. We'll delve into functional and non-functional security testing, different testing techniques, the role of the testing environment, testing standards, and the role of crowdsourcing in testing. Let's get started. Security testing is a crucial part of software development, ensuring both quality and security. It's essential for identifying defects and vulnerabilities that could increase risk. Effective testing must be integrated into the software build process, covering both functional and non-functional requirements. The first step in security testing is developing a comprehensive test plan. This document details a systematic approach to testing, starting with a test strategy that outlines the overall testing approach. From this plan, specific test cases are created, answering the question, what am I going to test, and what will correct look like? A robust testing plan should address several practical questions. Who is responsible for generating and executing the tests? Who will build and maintain the testbed? What are the criteria for stopping and restarting testing? When will source code be placed under change control? What level will anomaly reports be written for? The goal is to exercise the component's logic to expose any latent defects. Functional testing assesses the software's functionality as expected by the end user. It determines compliance with requirements in reliability, logic, performance, and scalability. This type of testing ensures that the software functions correctly at all times. Functional testing involves several steps: identifying the functions the software is expected to perform, creating input test data based on the function specifications, determining expected output test results, executing the test cases, and comparing actual and expected outputs to determine functional compliance. Unit testing is conducted by developers to ensure logic elements are correct and the software meets published requirements. It's the first level of testing and is essential for overall project stability. Non-functional testing addresses service levels of agreement, such as reliability, performance, and scalability. These tests are vital for ensuring ease of use and overall system functionality. There are different types of non-functional testing. Load testing involves running the system under controlled speed environments, while stress testing takes the system past its operating point to see how it handles overload conditions. White box testing involves full knowledge of the system's components, including source code. It's performed early in the development cycle to devise potential methods of attacking the software. Black box testing is conducted without any knowledge of the inner workings of the software. This approach focuses on the behavioral characteristics of the application, similar to how an end user would interact with it. Gray box testing is a blend of both white box and black box testing, with testers having partial knowledge of the inner workings of the software. The testing environment plays a critical role in the software development process. It ensures interoperability of artifacts and metrics between systems, which improves the usability of test results. Testing across trust boundaries from end to end of the application is crucial. A test harness documents the software, tools, data input and output, and configurations used for testing. Test scripts automate user actions, improving the speed and accuracy of test interpretation. Several standards guide security testing. ISO/IEC 25010-2011 provides guidance for establishing quality in software products, focusing on functionality, reliability, usability, efficiency, maintainability, and portability. The Systems Security Engineering Capability Maturity Model, or SSE-CMM, is an international standard for secure engineering, evaluating security practices across the lifecycle of a secure system. The Open Source Security Testing Methodology Manual, or OSSTMM, provides a scientific methodology for assessing operational security using analytical metrics. It covers data networks, telecommunications, wireless, physical, and human security testing. Crowdsourcing involves external parties, like hackers and security researchers, in the testing process. Hackers find holes in the software for exploitation, while security researchers report their findings to the company under responsible disclosure. Bug bounty programs reward researchers for identifying vulnerabilities, benefiting both the company and the security community. To wrap up, we've explored the comprehensive aspects of security testing strategies and plans. Remember, a test plan is crucial for systematic testing. Functional testing ensures software meets user expectations, while non-functional testing addresses service levels. Testing techniques like white box, black box, and gray box testing provide different levels of system insight. The testing environment and adherence to standards like ISO, IEC 25010 and SSE-CMM are essential for reliable results. Lastly, crowdsourcing can significantly enhance testing efforts. Thank you for joining this lesson on security testing strategy and plan. Understanding these concepts is vital for developing secure software. If you have any questions, feel free to reach out. Happy testing!